All right, so we have these topics for the review session, right? So, and this one. I told you that in the email I wrote we will have 2.2353. Okay, so basically separable equation, linear equation, Bernoulli homogeneous 3.1. So let's do some review. If you go to 5, 12, and 24. So I have 5, 12, and 24. So these are separable equation, and so section so in 2.2 we have separable equations. So in separable equation, this is the easiest of them all. So what are these? Here dy by dx will be written as a function of x multiplied by function of y, or maybe a function of x divided by a function of y, or maybe gx in the denominator. So basically x and y are separated, you see, either multiplication or division. So why we call them separable? Because I can separate the variables. So first step here is this. Okay, so if anyone comes, you can accept his request. Okay, I think you can also accept. I don't have to go there again and again. So what do we mean by separating the variables? This is only a function of x, so I keep it here. I bring dx on the right. And this is a function of y, so we send it here, down here. Okay, so you can see that if I bring hy down, you will have 1 over hy on the left side and only dy on the left. And gx is on the right side. So when you bring dx to the right, I will get dx here. So see, there is only x on the y on the left. You see, there is only y variable and there is only x variable. So you see, variables are separated. That's why we call it a separable equation. Variables are separated. So whenever you can separate the variable, you should do that. And after this one, this is the first step that separate the variables. Okay, and then after separating the variables, the second step is integrate. So if you integrate your left hand side with respect to y and the right hand side with respect to x, and you can get the solution, right? So this will give you the solution. Get the solution. Okay. So for example, if I look at problem number 5, x dy by dx is equal to 4y. Exercise 5, x dy by dx equal to 4y, right? So you see, from here, I need this dx to be on the right side, right? Dx here. But this x should not be here as well. So I should divide this x here on the other side as well. I should bring both on the right. So I will get dy is equal to 4y, and this becomes dx by x. But I don't want this y here. So you can divide y on both sides as well. So you see, y is also gone. So this gives you, so from here you got 1 over y dy is equal to 1 over x dx, 4 over x dx, right? 4 divided by x dx and 1 over y dy. So see, there is only y on the left and only x on the right. So variables are separated. This is what we have to do. So step 1 is done. After this one, just integrate both sides. So if you integrate, you got 1 over y dy is equal to 4 is constant. So you can write 1 over x dx on the right side. And we know that integral of 1 over y is log of y, and 4 integral of x is x plus constant of integration. We want to write y. We know that this, when log goes to the other side, it becomes exponential, right? Log becomes exponential. So this will become y is equal to e to the power 4 log of x plus c. You can further simplify this solution. E to the power 4 log of x separately and e to the power c, because the power is plus. So we can write the base with both the terms separately. E to the power 4 log x, e to the power c. This e to the power c is a new constant, right? It's a new arbitrary constant. Arbitrary means which can take any value. It's a new constant, so call it c again. Okay, just call it c instead of writing e to the power c. So if I call it c, I can write it c and e to the power 4 log x. I also don't want this 4 here. So if you send this 4 to the power, because it's the property of logarithm, you can write log x to the power 4, right? 4 went to the, so now why I did that? Because now e and log will cancel. Now this log and e will cancel each other because they are inverses of each other. So see, I got just c x to the power 4. So this is my solution. Okay, so my y has become cx to the power 4. So in separation of variables, this is what you have to do. Let's say I can separate the variables for this equation as well, and then you can simplify and solve it. Or this one, 24, you can divide y and x. So it is dy by dx is equal to y square minus 1 over x square minus 1. So see, I will bring this y square down here, right? And I will bring this dx up here. So it will become 1 over y square minus 1 dy and 1 over x square minus 1. And this dx will come here and will become dx. So very easy to separate the variables. So see, variables are separated again. In this step, your variables are separated. You only have y on the left and only x on the right. So if this is the case, integrate, right? That's the second step, that integrate once the variables are separated. Now you should know what are the formulas for that. So if there is some difficult integration, I will write it on the board. But this, I think, can be seen from the table. Integral of this is natural log of y minus 1 over y plus 1. And this is the same thing on the left and right. X minus 1, x plus 1 plus c. Okay. So I think if you look at the table of integrations, 63, at the beginning there is a table, or at the end there is a table of integration. So maybe at the end. If I go at the end. Simple integration, you should remember, like in previous question, 1 over x was log of x, 1 over y was log of y, like that. But this is little difficult. So if this is the formula, I will write it on the board. These are integration, I think, no? Probably not. I don't know. Or we can see from the calculus. This is the answers. This is the table of Laplace transforms, table of Laplace, answers. I'm not sure if the table is given.
So, Mister, you will write it in the board?
If it is needed, I will write it on the board. Okay. Usually, these are given at the beginning and at the end. Give me a second. Okay, so I think it's not given. Table is not given here. No issues. So in 2.3, it's a linear equation. In linear equation, you have to remember few steps to solve it because it's not same as separable. Linear equation is something like that. dy by dx plus a function of x only with y and function of x on the right. So y and dy by dx are fixed here. You have y and dy by dx. So this px and fx, they can be any functions of x. This is a first order linear equation. Okay. To solve this, we have two methods. First step is that you find integrating factor. Integrating factor. We define it like e to the power integral of px dx. You see this px. This px goes here. So whatever you get, it is a function of x, right? Then step two is multiplying equation by integrating factor. Multiply equation 1 by the integrating factor, whatever you get. Okay. And once you multiply this, and now see, you have to remember these steps. 2, 3 steps you have to remember. So if you multiply equation 1, you get mu x dy by dx plus px mu x y is equal to mu x fx, right? So you see, we multiplied mu x throughout with all the terms, After this step, you write left-hand side. Remember that left-hand side becomes the derivative of mu x, the integrating factor, into y, the dependent variable. Okay, so this is always true. And if it is not like that, you can check it backwards. Okay. Check backwards whether it's correct or not. And if this is the case, now it is a separable equation. There is only x on the right and this d is up front. So the last step is integrate. Okay. Integrate. So if I integrate d by dx of mu x y is equal to integrate mu x fx dx. So see, the derivative and integral cancel each other. So you get only mu x y on the left, and on the right, you get integral of mu x fx. Whatever the integration is, whatever answer you get, you add a value c here. And now for y, if you need to find y, you can just divide mu of x on the right side. If you can remember this formula, you can do it directly. I will accept it, no issues, but I will not give you this formula. Either you should do all these steps, or you can directly, after finding step 1, after finding this mu of x, you can put it here in the answer. Put mu x here and simplify. Okay, let me show you the example. You will see that it's in assignment, it is 3, 9, 25, 36. So let's see. 3, 9, 25, 36. The 25 is a initial value problem. That's why I did it. If the initial condition is given, this is to find the value C. To find C in your solution. There is nothing else. And 36 is this. So I can do one of them maybe. So what is the fifth equation? Dy by dx plus y is equal to e to the power 3x. Dy by dx plus y is equal to e to the power 3x. So you see, it's clearly a linear equation. Y and dy by dx are alone, and px is 1 here. You see, it's 1. If it is not written, it's 1. So here, px is 1. Px is equal to 1. So this implies that my integrating factor will become e to the power integral of px dx, which is 1 dx. So it is ex, right? This is my mu of x, okay? Integrating factor is mu x, we call it mu x, equal to, so I got ex. If you want, you can put it in the final solution here. If you remember this one, right, you can put it here and get the solution. So therefore, the solution, if you want to write it directly, if you don't want to do all those steps, you can remember it will become 1 over mu x is ex, integral of bracket, integral of mu x ex, and fx. Fx is the right hand side. This is your fx, the right hand side. So fx is e to the power 3x dx and plus a constant of integration. Okay, so if I put mu x ex and fx as e3x and now integrate. So 1 over ex, integral of ex and e3x becomes e4x. Before integrating, we should simplify. I can multiply ex and e3x because the bases are the same, so we can add the power, right? So x plus 3x will become 4x. Now integrate 1 over ex. So the integral will become e to the power 4x divided by 4 plus a constant of integration. Now you can multiply this inside. If you multiply this inside, it will become e to the power 3x by 4 plus c divided by ex. This is your answer. Okay, y is equal to e3x by 4 plus c over ex. Otherwise, you can remember these 3 steps one by one. You will get the same answer at the end. Okay, for example, if I don't want to do this one, right? So after this is the second method. Or after getting the integrating factor, what we do? We multiply over equation 1, the given equation, by the integrating factor. This was my step 2, that multiply equation 1 by the integrating factor. Integrating factor is ex. So see, my left hand side becomes ex dy by dx plus exy is equal to ex into e3x. See, I multiply my whole equation with ex here. You see, if I multiply ex, ex. So what I got, you see, ex dy by dx plus exy is equal to ex3 4x. So I can use this color here. So ex, we multiplied by that. Now, what I said, after multiplying, the left side automatically becomes the derivative of ex into y, derivative of integrating factor into the dependent variable y. This is automatically true. And this will become E4x on the right side. Now you can check backwards. As I said, you can check it backwards whether it's correct or not. So if you use the product rule, you will exactly get that. Okay, so this is fine. Now integrate. So the last step is integrate here. If you integrate, d by dx will cancel, equal to integrate e4x dx. So see, this is gone. So you got exy is equal to e4x becomes e4x divided by 4 plus c. And now if you divide ex on the other side, we got exactly the same solution which I wrote above. You see here, you can compare this with this. You see here, 1 over ex, e4x by 4 plus c. 1 over ex, e4x by 4 plus c. Exactly the same solution. So it's your choice now. You want to use the formula directly, or you want to use these 3 steps. Okay, so if you use 3 steps, then step 1 is finding the integrating factor. Step 2 is multiplying integrating factor with the equation, and step 3 is integrating the resulting equation. So this is your linear equation. And if a condition is given, you can find the value of c. If some condition is given, let's say if initial condition is given, IC is given, initial condition. For example, y at 0 is equal to 1, let's say, right? Then what you will do, you will use this x0 and y1. This is your x0, right? And this is your y. So x is 0 and y is 1. So if you use this one, y is 1, e to the power 0, x is 0, plus c e to the power 0 is 1. So see, you got 1 is equal to 1 by 4 plus c. So from here, your c becomes 1 minus 1 by 4 is 3 by 4. So now you can put this back in your solution. So if the initial condition is given in any question, not just in linear question, even if, let's say, separation of variables here, I think in problem number 24, some condition was given here as well. Okay, so what you can do, use that condition, use initial condition to find C. Whenever initial condition is given, you should use those conditions here in X and Y and get the value of C. That's the additional thing. Okay, whenever the condition is given, it is not just for linear equation. For any equation, if an initial condition is given, you can use that initial condition to find the value of C, like I did here. This is an extra thing if the initial condition is given to you. In 2.5, we had 2 equations. One is Bernoulli's equation and one is homogeneous equation. Okay. Bernoulli's equation looks like linear equation. dy by dx plus pxy is equal to fx. You see, up to this, it is a linear equation. But for Bernoulli's equation, we have y to some power on the right hand side. Okay. And homogeneous equation is you have the same degree. Okay. All terms have same degree. All terms have same degree. Okay. So these both are solved using substitution. So if you, in Bernoulli's equation, you divide this yn everywhere. Whatever you have here, just divide that everywhere. So see, this is cancelled. So you got 1 over yn, or you can write this as y to the power minus n dy by dx. Here, dy by dx plus px, and you see y has power 1 here and n here. So this will become y to the power 1 minus n. And on the right side, now you have only fx. After this step, this is first step. Step 1 is divide by yn. Now, whatever you get here, with px, substitute, call it u. U is equal to y1 minus n. This is the substitution that you use. Substitute u is equal to y1 minus n. And now if you take the derivative du by dx, it becomes 1 minus n y to the power minus n dy by dx. So you see on the left side, you have y minus n dy by dx, y minus n dy by dx, exactly same thing. So this is something which you can substitute here. Okay, so your equation becomes 1 over 1 minus n du by dx plus px, and this is u. Y to the power 1 minus n is u, and on the right hand side it is fx. This is your first order linear equation. You can multiply 1 minus n on both sides. So you got du by dx plus 1 minus n px u is equal to 1 minus n. 1 minus n is just a constant. It's a number. You can multiply. This is a linear equation in u, not in y now. It's in u. And we can use section 2.3 to solve it. Okay. So what I will do, if I ask you linear equation in the exam, okay, I will not ask you to solve it. Okay. If I give you a Bernoulli's equation, if I give you this Bernoulli's equation, I will ask you to use a substitution, use this substitution to convert your Bernoulli's equation to linear equation. That's it. And do not solve the resulting equation, because we know how to solve linear equation. Okay, so if I give you the Bernoulli's equation, I will ask you just this step, the first step, first two steps. Step 1 is divide, and step 2 is substitute. When you substitute this, you get a linear equation. That's it, just stop here. Okay, otherwise in questions, in assignments, you will solve it, right? In assignment like here, in this question, which I gave you from 2.5, let's say this one, you will solve it. Okay, but in exam, I may shorten this because in Ramadan timing as well, we don't have much time. So we can just shorten the question by not asking you to solve the resulting linear equation. So question number 5, I think I wrote from 2.5. So let me write that. Question number 5 is homogeneous. This is Bernoulli. This is Bernoulli's equation. Let's say 16. Okay. Let me do it later. In next page, I can solve this equation. Dy by dx minus y is equal to exy square. Right? So you see, this looks like up from here to here. It looks like linear equation. So what is extra here? The extra is just y square on the right. So this makes it Bernoulli. This makes it Bernoulli's equation. Otherwise, it looks like a linear equation. Okay. So what is the first step? First step is divide by y square. So step 1 is divide by whatever power you have on the right side of y. Divide by this. So you get 1 over y square dy by dx minus y over y square equal to ex, because here y square and y square will cancel, right? So now I can write this as y minus 2 dy by dx, and here it becomes y minus 1, because 1 minus 2, if it goes there, it becomes 1 minus 2, right? So 1 minus 2 will become minus 1 is equal to ex. So at this step, we replace this by u. We substitute this number by u. Substitute only the power of y, not px. Only the power of y. Substitute this by u. And then take the derivative. Du by dx will become minus y to the power minus 2 dy by dx. And you see, the first term is y minus 2 dy by dx. I don't want this minus, so bring minus here. Okay. So now my equation, this equation 1 becomes, therefore, equation 1 becomes y minus 2 dy by dx is minus dy by du by dx. You see here, y minus 2 dy by dx is minus du by dx, and minus y to the power minus 1 is u, and on the right side it's ex. And then we multiply this minus. If you multiply by a minus sign, this will become plus, this will also become plus, and this will become minus. Okay, this is the resulting linear equation. This is linear in U. Okay. So I will ask you up to this one. If you want to solve it, you can solve using the previous method, this method. Because it's a linear equation, we know how to solve it. But in the exam, I will only ask you to convert the Bernoulli's equation to the linear equation and stop.
Doctor, only will do 2 steps?
Yeah, only 2 steps. Okay.
Okay.
Third step is solving the linear equation, right? As I wrote this here, right? Step 3. But if you are doing this complete problem, you will do step 3, you will solve it. But if I don't ask you to solve it, then don't solve it. Okay. So equation, homogeneous equation is the second one. This is also used. You have some function of xy with dx plus a function of xy with dy equal to 0. Okay, and these both functions will have same degree terms. All the terms will have same degree. Okay, like if they have degree 1, you only have x and y terms. If it has degree 2, then you have x square, xy, and y square terms. If it has degree 3, then x cube, x square y, x y square y cube. They all have degree 3. This is degree 1. These are degree 2. These are degree 3. So all the terms will have the same degree, either this or this or this. Okay. You cannot have mixed terms here. So when this is the case in homogeneous equation, let me directly do the example here. I wrote 5, right? So this one. So you see y square plus yx minus x square. Y square plus yx dx minus x square dy. So you see both the functions m and n. This is your m function, this is your n function. They all have degree 2. You see, all terms have degree 2, same degree, right? So it means that given equation is homogeneous. So therefore, the equation is a homogeneous equation. So when it is a homogeneous equation, you write dy by dx. Bring x square dy equal to y square plus yx dx. Okay. Now bring this dx here, bring it down. Okay. And bring this x square down here, divided by x square. So we don't bring everything on the left. We only bring dy by dx on the left. It's not like separable equation. So I got y square plus yx on the right and x square on the left. So first step is that, step one here is that write like this. Write your equation like dy by dx and everything on the right. Okay. Then you divide the right hand side because they all have the same degree, degree 2. All have degree 2. You divide all the terms by x square. Divide all the terms by x square. You can maybe call it step 2. So it becomes y square by x square plus 1x is cancelled. So you got y by x and the denominator becomes 1. Okay. So you got dy by dx. So from here, you got dy by dx equal to y by x whole square plus y by x. This is basically your step 2. You have to write, after dividing, you have to write this as a function of, you see, this is a function of y by x. Wherever you see the variables, they are coming as y by x. Call this function some number and let u is equal to substitute. So here the substitution is u is equal to y by x. Y by x. So it means y is equal to ux. If you multiply u here, y is ux. And if you differentiate, dy by dx will become u into 1 plus x into du by dx, product rule. And now replace it in equation 1. So your equation 1 becomes dy by dx becomes u plus x du by dx. You see, dy by dx is this. So I replace it on the left because left hand side is just dy by dx. So this has become this equal to y by x square. Y by x is u plus u. Okay. And this becomes separable. This does not become linear. It becomes separable. Now bring this u here, make it minus u, right? So you got x du by dx equal to u square plus, and u minus u cancel. So you did not get anything. And now you can separate the variable. This is a separable equation. You remember how we separate the variables? So you can bring dx here and x here and bring this u down here, 1 over u square, right? So they cancel. So you got 1 over u square du is equal to 1 over x dx, separable equation, right? Variables are separated. So you can stop here as well. If I ask you, this is a very simple question. Now, if you integrate, you will get the solution. Minus 1 over u is equal to log of x plus c. See? Separable equation is very easy to solve. But sometimes this integration becomes difficult on the left side. So like the Bernoulli equation, I will ask you to use a substitution, right, to convert your equation to a linear equation, to this equation. That's it, and stop. Don't do step 3, right? And here also, if you do step 1 and step 2, then step 3 is to substitute u is equal to y by x. This will change your equation to a separable equation, okay? So this is a separable equation automatically. It's not linear equation. So separable equation, we are back to section 2.2. All right. But if I ask you to convert your equation to separable equation, you can stop here. If I only ask you to find the separable equation after substitution, that's it. If I don't ask you to solve, you can stop here in this step. Otherwise, you can complete. What is my u? U is y by x. So this becomes minus x by y is equal to log of x plus c. Right? And from here, you can find the value of y as well. So this solution is very easy because separable equations are easy. But this is, you will do this only if I ask you the solution. Okay? Only if I ask to solve completely. Okay. If I ask you to stop when you get the homogeneous equation, then you can stop here. No need to separate the variables and solve it. All right. And I think in Noodle, there is a video for 3.1. I think you can follow that. Here I wrote, I removed the video or what? You see here, a solved exercises, maybe not the video here. Growth and decay. So these are the problems, and these are some statement problems. From the statement problem, you have to write the equation, okay, and solve it. And mostly these are separable equations. This is section 2.2. Solving will be very, very easy. Okay. So if you go through these solved problems, from what are done here, they will be enough, I think. And I did in the class as well. I did few problems, you see. So example one, population growth model. This is important. Leave this carbon dating. Cooling of a cake. This is a good one, right? So let me shortlist some problems for you in 3.1. So in 3.1, you can just concentrate on growth and decay. Let's say this question, right? Population grows, the initial population increased by this one. Yeah, just concentrate on growth and decay, and Newton's law of cooling, maybe this one. So you can do from 1 to 9, these are population growth model, and 13, 15, these are Newton's law of cooling. Yeah, 13, 15, 17 is also Newton's law of cooling. Growth model, Newton's law of cooling, 21, 23. 21, 23 are mixture problems. So let's keep it easy. Let's just have these two. Even carbon dating, just leave it for the midterm. Okay. So just do these two. Population growth and Newton's law of cooling. So I will ask you one of them. So concentrate on these two things for the exam. We had population growth and decay. Anything, growth, decay is the same thing. Newton's law of cooling, and it is for warming as well. Temperature increases or decreases, we can use it for both. This population growth model also have two sub problems, half-life and carbon dating, right? But for the midterm, just concentrate on this one. Okay. These two. And then there is a mixture problem as well. So there are a lot of problems, but I think these two will give you enough practice as long as the right. So just concentrate on these two. So population growth and decay model is very easy. dP by dt is equal to kp. This is a separable equation. You can easily solve it by bringing P down, 1 over P dP, and bring T here. So K dt. Separate variables are separated, integrate. It is log of P is equal to KT plus C. Log becomes exponential on the other side. So P becomes e to the power KT into e to the power C. So from here, you will get P is equal to C e to the power KT. This is the solution. Then in your problem, an initial condition is hidden. For example, here they said, if an initial population P naught has doubled in 5 years. So see, two conditions are given here. They said initial condition, when time was 0, your population was P naught. And the population becomes double of P naught in just 5 years. So the population after 5 years has double. So see, two conditions are given. If you use this condition, P to the power 0 is C to the power 0 is equal to P naught. So E to the power 0 is 1. So C is P naught. So this implies that my P becomes C becomes P naught e to the power KT, right? From this equation. And now if you use the second condition, it will give you K. If you use the second condition, P at 5 is equal to 2P naught. P at 5 means P0 e to the power 5K. You see here, P at 5 means just put T is equal to 5 here, E equal to 5 here, right? So this will give you the condition. So that is 2P naught. P naught cancels. Take log on both sides. Log of 2, log and E cancel. So 5K is log of 2, and this will give you K, which is log of 2 by 5. So that's how you can find log and put it back now. Put it back here. Okay. So therefore, my P will become P0 e to the power K, whatever K you got T, because this is your K. Whatever you get, you can put it here. Okay, so this is complete now. Now, if they ask you anything, you can answer the question. They ask you how long it will take for population to become triple, right? So from here, whatever condition is given, they said find the time when your population becomes 3 times the initial population, triple, right? Population becomes triple means 3 times the population given. So you put P is equal to 3P naught and find the value of T from here. So solving this equation will not be a problem, but making this growth and decay model is the same. Exercise 1 was this one. Growth and decay model is the same for all of them. If you solve it, you always get this solution. You can directly write this if you want. And then some conditions will be given in your problem. Use those conditions to answer to find the value of C and K. Once the value of C and K are found, you can answer any question which is given at the end of the problem. So see in Moodle, you can see here there are problems solved in my notes as well, and in the past semester as well. I wrote here that a few solved exercises from past semester. Let me check. Contains solutions of a few problems from section 3.1. No, I don't know. Maybe yeah, it was done on the board, so maybe that's why it does not have a video. Okay, so these are done on the whiteboard, and I took the pictures and made one PDF file and uploaded it. So question number 1 is done. Question number 3 is done here, and 15 is for the Newton's law of cooling. So see, I did 1, 3. This is done in the question. This is done, and question number 15 is done here. Okay. So for the practice, you can do this problem. For practice, you can try this. Okay. And here, I think these are enough, 1 and 2. If you want, you can try some other. Let's say this question is also that. You can try this if you want. So if you do these 2 questions, I think question number 4 and 13. 1, 3, and 17, 1, 3, and 15 are solved on those notes. Look at those questions and try to solve question number 4 and 13. They will give you enough for your exam. Anyway, I think this will help you now. It's already very late,
Master,
so try it. Yes.
just we have to review 13 and 4.
For your practice, I said 1, 3, and 15 are solved. So just look at these 3 questions from here. Question 1, question 3, and 15. Right? Based on these questions, you can try question number 13. 13 is also solved here. So see, 13 is also here. So just look at this one. And you see, 13 is also solved. Newton's law of cooling. So this is also done for you. So maybe just go through these exercises. Leave this 21 because I said leave the mixture problem and leave the carbon dating as well. Okay. So for now, just leave these 2. Do 1, 3. And now I can see this is also solved. That is also solved, so no need to. So just look at these solved problems. 1, 3, 13, and 15. If you just see these on your Moodle and try to repeat them, that's enough. Okay. Even if you don't want to do this 14, 4, no issues. Okay. So if you just look at these questions which are already solved on that Moodle, 1, 3, 13, and 15. So if you see these 4 questions, I think they will be enough. All right, I hope this will help you. So I will just upload this record.